Hi everyone, it's Miss Anhire here. I know you guys have started the Standing Waves Lab, and during tutorial I had quite a few questions. So I figured I could create a video for those of you guys who are still struggling with it. This type of wave with one open end was probably the hardest waves to find patterns for. So I figure if I walk you through the hardest one, you should be able to figure out the two fixed ends and the two open ends pretty easily. And if not, you're always welcome to reach out to me and attend the next tutorial to ask questions. So let's click on the website to get to the simulation, and it takes you to the two fixed ends, which you guys should be able to do on your own. I'm going to go to preset waves and choose one open end. And I'm going to hide the blue and the orange wave just to keep things more simplified. And what we want to find are the nodes, antinodes, and number of waves. You're also going to do a sketch. But what I'm going to add to this sketch is also a value for your wavelength. So that's given down here in centimeters. We're going to convert it to meters, and that is going to be important when you go to your Flipgrid question that you have to answer. Okay, so nodes. Nodes are the points at equilibrium. That means that they do not move from the equilibrium point. And a good way to memorize this definition is that we learn from kinematics displacement means the distance an object moves. Well, this node or this point has no displacement, which is why we call it a node. Now, the antinode has maximum displacement. So it goes from trough to crest and back to trough again. So we want to count those maximum points as your antinodes. So for this one, we've got one node and one antinode. So I'm going to write that here. And then we want to count the number of wavelengths. So for the first harmonic, I want you to notice that wavelengths usually go from the equilibrium up to a crest, back to equilibrium, down to a trough, and back to equilibrium. This only has one crest, and that would constitute, it doesn't even go back down, that constitutes just 1/4 of a wave. So anytime you just have equilibrium to crest or equilibrium to trough, you've got 1/4 of a wave. So let me add my sketch here. I'm gonna draw that wave, and then I want to also add, because this is going to be important for your Flipgrid, the wavelength. I'm going to convert my centimeters to meters, 2 decimal places to the left, which gives me a wavelength equal to 30 meters. Okay, going to the next harmonic, I've got 2 nodes. Remember, that's our equilibrium point. If we see it moving, there's no displacement at those 2 equilibrium points, and then there's max displacement at the trough and the crest. So I've got 2 nodes, 2 antinodes. You can already see a pattern in between the node and the antinode, right? So let's just see if that pattern continues. I want to count the number of waves. Now, a little tip I have for you is if the first harmonic is in terms of quarters, you want to count the future wavelengths in terms of quarters. So let's look at this. This is 1/4, 2/4, 3/4. We would get 1 full wave if this returned back down to equilibrium, which it doesn't. So we're going to write 3/4 in the number of waves. And I'm going to draw my wavelength here. So it goes from equilibrium to crest, down to trough. Let me make sure that looks right. You can draw it the other way around, it would still be correct. Wavelength, again, I've got 1,000 centimeters, which gives me 10 meters. So I'm just going to copy this to save time, change that to 10. and then moving on to the next. Notice I've got 1 node, 2 nodes. Can you predict how many nodes we'd have for the 5th harmonic? All right, let me play this. We've got 1, 2, 3 nodes. Hopefully you got 3 nodes for your prediction. And if we have 3 nodes for our 5th harmonic, we should also have 1, 2, 3 antinodes. So here's your pattern. It increases by 1 each time. Let's check out the number of waves. So let me pause this. I've got 1 quarter, 2 quarters, 3 quarters, 4 quarters, 5 quarters. Like I said, count it in quarters. I know you can see you've got 1 full wavelength and then a quarter of a wavelength, but it's a lot easier to see the pattern if you leave it as 5 quarters rather than 1.25 or 1 1/4. So I'm going to write it out as 5/4 of a wavelength. I'm going to draw my wavelength starting at a crest just to keep it all similar. 1 full wave and then 1/4 of a wave. And then we'll go back and check out what our wavelength is. Here we've got a wavelength of 6 meters. Next one, I think you can see a pattern. So it should increase by 1. So I'm going to go to 4, 4. And then do you see a pattern here in terms of number of waves? I go 1/4, 3/4, 5/4. It increases, the numerator increases by 2. So we're going to make a prediction that the next one is 7/4, and then let's actually check that. We want 4 nodes, 4 antinodes, and 7/4 of a wave. So next harmonic, we've got 1, 2, 3, 4 nodes, so that's good. We've got 1, 2, 3, 4 antinodes, perfect. And then how many waves do we have? We have 1 quarter, 2 quarters, 3 quarters, 4 quarters, 5 quarters, 6 quarters, and 7 quarters. So 7/4 of a wave, which is exactly what we predicted here. So let me draw. Let's check out the wavelength. There. Okay, so wavelength here is a funky number. So if I convert that to meters, I get 4.286 meters. So I'm going to take my wavelength, change that to 4.286, and then let's go to the hard part, which is starting to find a pattern. Now, I want you to look at the nth harmonic, meaning when I change harmonics, how can I get from this value to this value? This took me quite a lot of time to figure out. And actually, if we look at this pattern right here, from harmonic to number of waves, you can see the pattern a lot easier. First harmonic, 1/4. Third harmonic, 3/4. Fifth harmonic, 5/4, so on and so forth. So let's just fill that one in because that one's the easy one. The hard one is the number of nodes, and after a lot of playing around with values, you can notice a lot of patterns from this. The first pattern I noticed was that going from 1 to 1, 3 to 2, 5 to 3, I was actually subtracting 0, subtracting 1, subtracting 2, and subtracting 3. So I noticed that as I was going from harmonic, if I subtracted a value and increased that value each time, I would get the number of nodes. Unfortunately, that was a really, really hard pattern to figure out. So after a lot more speculation, I noticed that if I added the number 1 to my harmonic, so 1 plus 1, and divide it by 2, I could get my value. So it's easier to notice the pattern if you work with maybe 3, 5, and 7. So I take 3 plus 1, which gives me 4, divide it by 2, and I get 2. 5 plus 1 is 6. Divide that by 2, you get 3. 7 plus 1 is 8. Divide that by 2, you get 4. So it's n plus 1, and divide that by 2. Let me just make this a little bit bigger. And then I'm going to copy that and paste that here because it's the same type of equation. Now, any other patterns you notice, you can talk about that down here. How to find the wavelength of the first harmonic. I kind of shared that with you in the beginning, so you can just type that out. And then the Flipgrid question asks you about how to find a pattern between the node value and the wavelength itself. So if you're going from 1 to 30, 2 to 10, 3 to 6, 4 to 4.286, wow, that's a really, really hard pattern to figure out. What I looked at, though, was when I went to the first harmonic, I noticed that this was just 1/4 of a wavelength, which means if I continued this wavelength, I would get 30 meters. Now, if I increased it, I squeeze more numbers of wavelengths into that 30 meters. And then again, more wavelengths squeezed into the 30 meters. So because I knew that we were taking a 30-meter value and adding more wavelengths into it, or squeezing those wavelengths into smaller and smaller values, I kind of figured that there would be some sort of relationship to 30. So I looked at my values. I start off with 30. That's just for one harmonic. And I noticed that to go from 30 to 10, I had to divide 30 by 3. Let me actually write this in here. If I take my 30 meters, divide it by 3, I get 10. If I take my 30 meters, everything is relative to 30. And in order to get 6, I know I have to divide that by 5. So I start to see a pattern. And I noticed if I go back up, obviously 30 with one wavelength in it is going to be 30 divided by 1. Now 4.286 is a really difficult fraction to figure out. So what I did was I looked at my pattern, 30 divided by 1, 30 divided by 3, 30 divided by 5, and I thought, well, this is increasing by 2 every time, so I'm going to try 30 divided by 7 and see what that gives me. Lo and behold, it actually gives me 4.286. So I did find a pattern, which is awesome, but the problem is I need to find a relationship between 1 and 3 divided by 1, 2, 3 divided by 3, 3, 3 divided by 5, and 4, 3 divided by 7. If you look at those values, you can see that to get from 1 to 1, you're adding 0. So 1 to 1, add 0. 2 to 3, you add 1. 3 to 5, you add 2. 4 to 7, you add 3. So let me see if I can show this relationship. So if I go from here to 1, I am adding 0. From 2 to 3, I am adding 1. 3 to 5, I add 2. And then, of course, you can see 4 to 7, you are adding 3. Okay, so from there, I knew that my equation would eventually be 30 divided by some number, and if I took my n value and added it to n minus 1, which would give me, for the first harmonic, 0, I would actually get that value. So here, 30, I took my n, so 2 plus 2 minus 1, which is 2 plus 1, I would get 30 divided by 3, and then so on and so forth. So you can see how that pattern works. This is your equation, so you could talk about that in your Flipgrid, or you can simplify it. I hope this was helpful. Don't hesitate to pop into a tutorial to get your questions answered, and good luck.